talking about logistics technology. So I'll go through the agenda part. So, elephant in the room, why am I talking about logistics? Followed by a little bit about the current situation, how it's characterized. Then look at some future trends. I'll go into some specific examples and then talk about the implications for the transportation systems. And all being well, there'll be time for some Q&A at the end. So why am I talking about this? Well, why not? After all, we always claim that systems engineers have this holistic through-life view of the world. And actually, it's quite good fun to go and play in support sometimes and go and see what happens after you finish doing the design. It goes into service. But the reality is, a lot of this material has come out from work I was doing for the last 2.25 years for DSTL on a project called Logistics Technology Investigations, where I was both the overall technical lead and also the lead for the autonomy and automation work package. And that particular work package was, as it says down there, interested in identifying the art of the possible in autonomy and automation as applied in the commercial world outside of defence, looking at some of those things to see how they might translate across, and then making recommendations back to my clients about which things they should go and pursue. Now, clearly, I won't talk about bullets 2 and 3 here, but I can talk about a lot of the stuff that was the open source research under bullet point 1. And of course, worth noting that we went from doing paper studies to actual proper physical trials and demonstrations. So at the bottom there are some photographs from a quite muddy, wet field last autumn, where we tried out various technologies and even some robots. And it is worth noting that defense tends to be quite kind of low volume, high diversity, whereas commercial logistics tends to be quite high volume but quite low diversity. So there were some quite interesting mismatches that we encountered a lot along the way. So the sort of current state of logistics, in physical terms, it's all about pallets, shipping containers, kind of big chunky things that haven't changed much in quite a few decades, to be honest. I mean, there are various standards you can go on, so there isn't exactly a standard pallet, but there's a range of standards to choose from. The shipping container is very much a dominant thing, either 20-foot or 40-foot variety. And of course, they are intermodal by design, so you can get the same kind of containers on the back of lorries, on the back of trains, on the back of ships. You can stack them and rack them, you can do all sorts of things with them. So actually, as an intermodal idea, it's pretty good. It fits really well with any kind of operating model where you're trying to move stuff in bulk. So typically your pallets, stuff on top, cling film, strap it all down, back of the container, off you go. That works very well. You're typically looking at unloading and loading using forklifts and then cranes to move the actual containers themselves. And then air's a little bit different in that the pallet sizes are slightly bigger. They quite often have these customized unit load devices that fit the particular dimensions and shape of particular aircraft. But in principle, it's kind of similar. So bits of wood, shipping containers, sometimes these little kind of trolleys on wheels you can see in the third picture there. But it's all fairly standardized and has been for many years. If you flip across the digital world, that's where all the real advances have been made. So if you think back, in some ways it's all that magic. I can sit at home nowadays. I can choose things I want to have. I can summon to my door. They'll arrive. I can watch their progress on the map sometimes. Stuff I don't want, I can send back. I can do all this without setting foot outside the house, and that's compared to when I grew up, that's just magical nowadays. And of course, it's all underpinned by lots and lots of data. So you can now get global visibility of assets and items right across the world, right through the supply chain. And by having that visibility, it also gives you the platform for doing lots of good stuff that we now see. So the ability to optimize routes and loads of vehicles, the ability to do predictive maintenance for assets, the ability to improve your demands, planning and stock management, the fact you can assure delivery of specialist items, so things like blood or medical supplies that have to be kept at certain temperatures and kept away from certain shocks and things, that can all be monitored end to end, and you can have refrigerated containers. All sorts of things can be done to make sure that that stuff arrives as it needs to arrive for the end user. You can optimize your warehouse layouts. Lots of automation there. If you've seen the Ocado or Auto Store, that sort of thing, there's an awful lot of robotics happening nowadays to optimize the way warehouses are laid out. We're now seeing dedicated reverse supply chain specialists, the people who will take on the job of returning the items, doing the triage, doing the disposal, doing the resale, retagging. All that can be done for you rather than having to do it in-house. We're seeing the rise of digital logistics marketplaces. We're seeing some quite good, quite sophisticated simulation models going on. So it's all happening. And if you want to know what's happening, a very good source to use is the DHL Logistics Trends Radar, which has been going for a few years now. We use the 4th and 5th editions in our study. The 6th editions come out fairly recently. This is a great quote. I won't read the whole thing, but essentially, thanks to globalization, the rise of e-commerce, technology disruption, and of course the COVID pandemic, which has caused huge changes to how all this works, there have been some big shifts and a real kind of move towards digitalization as the way forward. Now, within this report, there's a kind of PDF version and a website version. What you'll find is this thing that they call the radar plot, where now is in the middle, where the red dot shows. The outermost ring is 10 years into the future, and they have this kind of 0 to 10 sort of near to far horizon. To the left is societal and business trends, to the right is technology. And what they're doing is plotting kind of interesting stuff that's either happening in the world or happening in technology that might be of interest to logistics. And then over time, you can sort of track how these things have moved around. So one thing that was of interest to us in particular was that when we started the work, the idea of low-cost sensors, so that combination of temperature shock, humidity, maybe GPS, some kind of comms, so near-field comms or RFID, Bluetooth, or 4G, 5G even, that kind of combination of things, it was in that kind of near-term area, is now dropped off completely because it's seen as being ubiquitous. And that's quite true. When we did our demonstrations, people turned up with these big suitcases full of almost a mix and match. What do you want? So we put a sensor for that. So there's an awful lot going on in that space. I'd encourage you to have a look at this in slower time, but I'm going to pick on 4 of these things for the next part of the talk, which should be of interest to this audience. So I'll talk about smartification, not my word, but you'll see what it means, physical internet, outdoor autonomous vehicles, and digital twins. So start off with smartification. So it's the idea that you retrofit sensors to existing assets, or you add new technology to existing solutions to give you the old thing but better. So a smarter version of what you had before. It's not that new a thing. In the I've certainly worked on projects where we've taken in-service assets, we've retrofitted sensors, we've done interesting stuff with hums and fleet-wide maintenance. But it's becoming more and more prevalent. This idea you can go to old things, stick on new sensors, give them a new lease of life, and find out what's going on. There's also a lot of interest in tracking vehicles, so tracking and monitoring them, not just to know where they are, but to start to do clever things with traffic management. And as we just said, the packages themselves are becoming smarter. So what was just a package with a barcode, you can now start to embed all sorts of sensors and comms onto it and actually get quite an interestingly aware thing going on. And we'll talk a bit about that a bit more later. We also mentioned outdoor autonomous vehicles. So this is the classic thing you see, these little last mile delivery robots. Grab all the headlines for good and bad reasons. I'm sure some of you will have seen these things being stuck in snow in Estonia, being sort of lifted back on the pavement and pushed off again. Sometimes being interfered with in less happy ways. But essentially, they're there. People are trying to play with this technology. They've got challenges, particularly in open and dynamic environments, but it is a thing that's out there and it's kind of being played with. If you go to more constrained environments, there's a lot of stuff that's here, there, now, and part of the thing. So I quite like the picture in the bottom left there of the tow barless tug. So what it will do, it'll either autonomously or under remote control move an aircraft. So it clamps onto the nose wheel. It can then push the aircraft around wherever it needs to be. So rather than having a tug machine with a tow bar taking up lots of space, this thing gives you that real kind of pinpoint accuracy. And you'll find these on airfields, aircraft carriers even. You'll find them in hangars and workshops and warehouses where they can move these things around following predefined routes, and it just takes effectively a job that we need 7 people to do down to effectively 2 to watch, and the machine does the work. Similarly, you'll find automated forklifts, automated robots doing various things inside warehouses. They all need to do route planning. They all need some kind of collision avoidance, but clearly the strategies are quite different depending on the state of the environment you're operating inside. The more you can control it, the easier your life becomes. Another big thing now is digital twins of supply chains. So rather than being a digital twin of an asset, a kind of physics-based thing like you might find a gas turbine engine, it's actually about the whole supply chain. So can you track what's moving where, who's carrying what, where things are being stored across your whole supply chain? And if you can track that well enough, that lets you start to think about doing what-if scenarios and do some real planning And the Port Authority of Singapore are very interested in this because they have a very congested space and they're really trying to sort of maximize throughput. And so this sort of thing, once you've got the item and asset visibility in place to know where things are, it's the kind of second, third, all the thing you can build on top of it. And it's certainly a big area where we're starting to see some of the simulation tools are now being fed real data and actually giving real insights back again. So definitely a very growth area. The final thing I want to talk about in this little section is the physical internet. So it kind of started as a manifesto in 2011 by a guy called Benoit Montreal, who's Canadian, French Canadian, as you might guess. And he had this this view that to tackle the world's sustainability problems, logistics has to change. And his key concepts were around the idea of modular smart containers that are actually designed to fit together, stack together, and kind of create these bigger, kind of bulkier footprints by all being designed to fit together in the first place. The containers will be shared across the actors in the supply chain. The containers would know where they are and where they want to be and where they want to go next. So like IP packets declaring I want to go here, who can take me? And then the logistics providers and public sector actors would collaborate together to make the transportation delivery actually happen across the supply network. So you can see a lot of resonance there with the previous talk about ability to service, in that you've got this combination of people expected to work together to make it all happen. And then it's supposed to address a whole range of perceived problems with sustainability, such as the proliferation of empty containers around the world and boxes stacking up and never being used. It's a great idea, and bits of it are kind of happening. So it spawns a fair bit of EU research. So the ICANNET project in particular is very worth looking into. It's renewed interest in the world of sub-ISO and sub-pallet containers. So people are starting to think again about, is the pallet really the right size? And in some urban environments, actually going below pallets is good. The previous slide with the robots on, they're clearly operating some kind of sub-pallet container size, and maybe that will standardize. Equally, the sub-ISO world, there have been quite a few efforts over the years to try and create something that isn't as big as a shipping container. They've tended not to work so well, just because the shipping container is such a well-known standard. It's difficult to get enough momentum to get the change. And one quite interesting thing we found was actually that there are some places, and the example we found was a Menace distribution up in Scotland. So all the UK delivery companies want to claim complete UK-wide coverage for their service, but they don't all want to send a van with a single parcel into the Outer Hebrides or somewhere else that's very far away. So what's now happening there is there are companies that act as carriers. So you can't book with them directly yourself as a customer, but there's a business-to-business arrangement where they will take on the delivery on behalf of all the different carriers into those remote locations and effectively deliver in a kind of non-branded, non-threatening, non-competitive way to people out on the Isle of Skye or something, or wherever it might be. So some places that are a long way away that are hard to get to, and they effectively specialize in the remote delivery, and they can get enough business from all the different suppliers that they can then effectively run that part. And I think they're looking at similar models now in some urban areas too, where it's difficult to get in, but actually not everyone wants to send all their vans in there the whole time. So bits of this are starting to come, and of course, to do that, they have to collaborate with the other people. They have to talk to their IT systems. They have to actually make the whole thing work digitally as well as physically. So yeah, it's an interesting space to be in. So those are a few interesting trends. There are other ones clearly on the map to look at as well. But we did say systems of systems. So just a bit of a recap on what we really mean by that. Now, the example I'm using here is an airliner. So for an airliner, it clearly can be part of lots of different systems. I mean, for the pilot and crew, in fact, more to the point, without the pilot and crew, it's not a system. It's just a bunch of, it's a lump of metal, plastic, fiberglass, other composites. It doesn't do much by itself until there's people that's going to work with it. And so that's very much how you might just perceive the system working. But of course, to a holidaymaker, it's just a means to end. It's a way of getting from A to B to go on holiday, a necessary evil. If you're lucky, it's the place where you get refreshment, sleep, and maybe a bit of entertainment. If you're a design engineer, well, it's your life's work almost. It's a thing you've spent your whole time doing. As a manufacturer, it's a thing you build, integrate, push off the production line onto the next one. Chief financial officer, well, it's actually how you make money. It's just part of a money-making scheme, if you like. As a logistics company, well, it's the way in which you can move freight, little more than that. And for air traffic control purposes, it's just another thing to move around the map. They're all different systems that this airliner can play a part in. They're all different systems and systems that overlap. The main thing is you couldn't draw a sensible line around all this and say that is a system of systems in its own right. So what we're really saying is that it's more than just big systems. It's that reality of when operational or managerial boundaries of your system of interest and other systems of interest overlap in ways you can't just easily resolve, and it leads to emergent performance and capability and sometimes emergent complications. Because you're dealing with complex systems, not developed at the same time, not developed by the same engineers, usually not developed coherently, not necessarily developed with the same capability in mind, and potentially with unknown future needs, you have to kind of second guess a little bit. So with that in mind, I'm going to talk about some of the implications of the trends within a systems of systems context. So let's talk about data management. So Internet of Things, all these devices out there, everything wants to gather data, everything wants to communicate. How best to do this? So you could argue that every package could communicate by itself independently. So the real kind of nirvana of the physical internet, everything gathers, everything talks. You can try and bundle up by consignments, bundle up by pallets. There'd be various ways you could try and concentrate the data together, but then they sort of depend on how you're running the logistics side of it. And does the vehicle need to know what's inside? Is it just about consignments? How exactly do you want to do this? And there's a thought experiment I had about suppose you have a lorry containing lots and lots of smart containers, and it needs to brake suddenly on the motorway. Now, what would happen if all those smart containers all start independently reporting that they've had a acceleration exceedance event or shock exceedance, and they all start blasting out their problems, and it actually means that the lorry trying to tell the digital highway services on the actual road about the fact it's braking suddenly to warn other road users doesn't get through because everything's talking at the same time. There's all sorts of interesting kind of things to think about in terms of how you'd automate the reporting and how you kind of understand the priorities here. So there's other things here as well about generally tracking stuff. So we're used to seeing little maps of things on nowadays. That's not entirely new, but to know kind of when and where items are subject to these exceedances, so shock, temperature, humidity, and so on, it brings on the one hand lots of new assurance ideas. So you can actually kind of really assure what's happening when. There's also liabilities. There's also ethical concerns about monitoring of staff and kind of the effect that might have on people and how they behave. And of course, the technology itself is still evolving, so you don't want batteries on the entire. You don't want the devices on the entire time because that drains the battery. So there's some quite interesting work around wake-up techniques. So wake-up radios are quite an interesting thing to get into. And of course, as we've said several times, this is the kind of precursor to all the other good stuff around digital supply chains and digital supply chain twins. On the digital front, data science. We found lots of opportunity to really make the use of efficiencies coming out of data science work. So there are old problems like the knapsack problem. Kind of how do you best pack a particular space, which have been around since the 1870s. Nowadays, you can solve them quite easily for sort of a range of situations in time periods that are useful to people in their daily lives. So we saw lots of good examples of how to optimize a mixed load within the 1 meter space envelope of a pallet, and getting some very impressive results on that, far better than humans could do. You can look at optimizing across a series of pallets or containers and optimizing for order of delivery. There's lots of work now on optimizing journey routes, which is a thing which is now quite feasible. And of course, ultimately, that could lead to some quite good sustainability benefits from the more efficient use of vehicles, so the less vehicles, or vehicles being better packed. And really, from a systems perspective, it's then down to how do you combine that knowledge of what's available in the fleet with what's to be transported, where it needs to go, and all those kind of cross-docking and intermodal delays, because there's no point rushing everything around if there's then a 2-day wait for the ship to arrive. There's no point having very efficient, automated unpacking and unloading if it turns out that the things aren't there to go, or they're going to sit there for 2 days. So you still have to think about this with a slightly more open and systems mind than just the pure technology. And the final one here then is about autonomous vehicles and autonomous deliveries. So if you can imagine a future where you have autonomous last mile urban deliveries being routinely conducted by both things that fly and things that go on the ground, and at the same time we mix in self-driving cars and automated VTOL air taxis, how do you solve this problem? How do you stop these things colliding? What cyber vulnerabilities do you create in doing so? So it's one of these things where there's not one obvious single owner or regulator, but there are a whole bunch of interacting systems that need to be somehow deconflicted and kind of organized. I have colleagues that work on future flight. They've got a bunch of ideas, no definitive answers yet, because it's one of these things where, yeah, there's lots of possibility and lots of possibility for good and bad, but it does need some quite serious systems thinking. So on that note, I shall end. Any questions?
Hi, Ian. Fantastic. Thank you very much for that. Again, another really interesting talk. I've been taking down notes in the background as well. Just a few sort of questions. I'll skip mine to prioritize others. But we've got one from Stephen down there, which was talking about the fact that actually the physical internet concept that was put forward there, you know, and then sort of any new technology concept that comes in that would affect the system of system level. How does a roadmap look for that to go from essentially what is a cool idea to actually widespread stakeholder acceptance and adoption?
So we've seen of it is there's a kind of cherry picking by the big players, not a complete surprise here. So if you want to achieve mass integration across a big scale, then one way to do it is to buy everything or make everyone conform. So there's actually if you've heard of Alibaba, which is the kind of Chinese equivalent thing to Amazon, they've got, I forget the name, but they have basically distribution and logistics, if you like, which turns out to have this idea that they claim to deliver anything within 48 hours from China to the rest of the world, and they've essentially enforced a whole bunch of standards and protocols across everyone that's playing their space. So a very top-down approach, and that's embedding an awful lot of the kind of the mechanics of Pi into its work because it has to.
Mm.
So that sort of thing. And similarly, Amazon, of course, run a quite pick words carefully. They have a dominant position, and they're able to kind of behave in certain ways to their supply chain to make sure that things are all coherent. So I think it's the kind of the nice sort of grassroots up thing probably isn't happening, but I can see the impression you get from a lot of the reports is that the big players have seen it. They like some bits of it. They don't like the loss of brand identity at all.
Mm.
As you might imagine. So the thought that DHL will deliver an Amazon parcel for you on behalf of, I don't know, Royal Mail, that's not a thing people like very much. But the idea of doing it inside their own ecosystem where they can sort of band together and create their own pools of people all work a certain way, that's probably where it's going to go. And the actual containers themselves, the Pi container thing, yeah, the standardization is difficult. Once again, you'll note that once again, some parcel delivery people appear to have very standardized boxes. And that's what they've chosen to do. So I think within some places, that's definitely happening. The notion of the kind of packable thing that composes to a meter square box, I think, is still a way off.
Yeah, fair enough. And then just one other quick question, so I'm going to have to move on, but it's a topic that's close to my own thinking a lot of the time as well. Is with these, how are the needs of the voiceless captured within a systems engineering approach, particularly around the autonomous side of things? So we're talking sort of people that might suffer from visual impairment, and ensuring that we're not blocking up roadways with delivery bots, when actually a wider space might be needed for people that have accessibility requirements.
Yeah, which is where the cool idea is to meet the concrete of reality, isn't it? Clearly, yeah, I guess it comes down to regulation in the end, doesn't it? There has to be a proper thought given as to the needs of all the users of these roadways and pavements and everything else. And yeah, I think the idea you can assume you can run robots down the pavement and they'll mind is probably fine for a trial, but not so fine for real life.
And I think that
It's the
that's
same
just
as
a
the
really
autonomous air delivery stuff is fine when you've got nice corridors defined.
yeah.
But it's not
I
so
think just,
fine if you're doing it the whole time.
I think just an interesting sort of thought for myself on that one. It's interesting that how the two answers just there are quite intertwined, because if it's relying on, say, the big behemoths of industry that are coming up with all these systems and containerization of things, they need to be regulated to actually have these considerations as part of their design, because otherwise they're just going on with what is the most effectively business efficient solution.
So you're back to the first presenter then, really. In the places where culturally there's a regulator, the regulator's up. In places where culturally there isn't one, be scared, I guess.
No, brilliant. Thank you very much for that. I'd like to